Well, hi everyone, and greetings from Northern Michigan. This is Bob the Science Guy, and today I need to put some things to bed. Now, lately, the flat Earth community, including some of the talking heads like Nathan Oakley and Quantum Eraser, and apparently their new hero, Brian's Logic, have been trying to make the case that somehow a sextant proves that the Earth is flat. Well, obviously, nothing could be further from the truth because a sextant in reality will not work on a flat Earth, and it proves conclusively that the Earth is spherical. So I thought what I would do is I would put together a brief presentation on exactly why a sextant will not work on a flat Earth and how it proves the globe. So let's cue up the music and kill some flat Earth dreams. One of the biggest problems with the flat Earth is the inability to understand and comprehend actual evidence and what that evidence is showing you. Because what they have is they've got a narrative that they have to follow. And they have to try and interpret their evidence or what they see in light of their narrative. And if it doesn't fit their narrative, well, they come up with reasons to make it fit. And it's just stupid. So, for example, Nathan Oakley came up with this silly little attack piece on me the other day. And he tried to say that a sextant proved the Earth was flat. But this is a screenshot from his actual video. And if he had only looked at it, he would have seen the problem. So let's go ahead and look at it real quick. You're all very familiar with this right here. And this is basically the Eratosthenes experiment. Now, Eratosthenes had a well in Syene, Egypt, that was literally on the Tropic of Cancer. And on one day a year, the sun shone directly down that well. So he could verify that this ray of the sun was striking the Earth in a perpendicular fashion. Then he went up to Alexandria and he put a vertical stick in the ground and he measured the angle that the shadow formed on that stick. Now, his assumption at the time, and it was a valid assumption, is that the rays of the sun are coming in parallel. And because that is indeed the case. Now, they're slightly off because the sun is not a point source of light, but they are essentially parallel. Now, here's the problem with the Eratosthenes experiment and how it relates to sextants. Now, the geographic position of the sun is directly over Syene. That's why it is at the zenith and it's shining straight down the well. That's the geographic position. Now, when you go north to Alexandria and measure the shadow there, you find that it is 7.2 degrees. And what Eratosthenes did was he said, well, 7.2 degrees around the 360-degree circumference of the Earth equals 500 miles. Therefore, this total circumference of the Earth is about 25,000 miles. And that holds up pretty well to modern determinations of the circumference of the Earth. Now, I've done the Eratosthenes experiment on a number of occasions and come very close to the actual radius and circumference of the Earth. But here's the problem that you run into. You don't know for sure if you're looking at Syene here and Alexandria here. Are you looking at a curved surface or are you looking at a flat surface? Well, the answer to that is very easy. First of all, if you're looking at a flat surface, you could triangulate the distance to the sun. Now, if you know the distance from here to here, and you triangulate the distance to the sun from here to here, you will be able to predict this angle because you can know this distance right here. It's a very simple matter. The problem that you run into on the Earth is if you take the known distance between this pole and this pole, and that angle, and you calculate or triangulate the distance to the sun. If you take the distance from here to here, given that same distance to the sun, it doesn't work out. The only way it works out is if you have a different distance to the sun. So in other words, at every measurement point beyond the first two, you have to change the distance to the sun in order to make it work. Now, if you look over here on the spherical Earth, with the rays coming in parallel, they do match up. They match exactly. You can easily predict these angles if you know that angle and that distance. And here's why that is. All right, let's take a flat Earth right here. And we have a series of sticks, and they're all in parallel, and they're all the same size. If the rays of the sun were coming in parallel, because the sun was very far away, what would happen to the shadows? Well, they would all be exactly the same, wouldn't they? So would the Eratosthenes experiment have worked? Absolutely not, because the shadow in Syene would have been exactly the same as the shadow in Alexandria. Now we know that there's a difference in the shadow at different locations. Why? Historical records from Eratosthenes, people like Blue Marble Science and myself and B-Ball for Life have all done the Eratosthenes experiment, and we got different shadow lengths. So this situation simply is untenable. You simply cannot have parallel rays of light on a flat Earth and get different size shadows from the same size and parallel sticks. You just can't do it. Okay, problem number 2 with the flat Earth. If the sun is local, you can indeed have no shadow at Syene, and you can have a 7.2 degree shadow at Alexandria. However, if you plot out additional shadows, they will all go back to exactly the same point. This doesn't occur on Earth. Now, how do we know that? Well, I did a measurement between Michigan and Tennessee, and the difference was some 400 miles for the height of the sun. I also did a measurement from Michigan to Hawaii, and the difference was also hundreds of miles. Now, let's go ahead and look at a curved Earth at a local sun and a distant sun. Okay, same situation. We have the geographic position of the sun over Syene, and the sun is local. So this is a fixed distance right here. Now, since that's a fixed distance, this stick's shadow will line up with the sun. Likewise, this stick's shadow will line up with the sun. And finally, that stick's shadow will also line up with the sun. These two shadows don't even hit the Earth. We know that's not the situation. If that was 7.2 degrees, we could predict what that shadow would be. And when we actually measure the shadow, it's not what we predict based on a local sun on a curved Earth. Let's look at the final situation. Okay, now in this situation, we have a very distant sun, and here is the geographic position of that sun. Now, with a very distant sun, the light will come in parallel, which means that the light hitting here will be at that angle, hitting here will be at that angle, hitting here will be at that angle, whoops, that angle. Same thing down here. Now, with this situation, both south and north, those shadows will be very predictable. We could calculate what they would be. So if we know the shadow at Syene is 0, and the one at Alexandria, 500 miles away, is 7.2, we can accurately predict these angles at all of these other points. And that is the case that we find, because the Earth is spherical and sunlight comes into Earth roughly parallel. A lot of people in the flat Earth and conspiracy theorists that are trying to overcome this basic truth say that the light isn't truly parallel. And that's true. That's why we have halos around shadows, the penumbra around the umbra. And that's because the sun is not a point source of light. It's about half a degree in diameter. So you're going to get some light from the top part of the sun, the bottom part of the sun, and the middle part of the sun. And as a result, you're going to get that little halo around a dark shadow. It's very well understood. However, the rays are parallel enough to be used accurately for navigation to pinpoint our location on Earth within a mile or two. So what this section has done is it's shown conclusively the sun cannot be local on either a flat or a curved Earth. And if the sun's rays are in parallel, as we say, and as we have measured, the only solution that fits is a curved Earth, because you cannot have a flat Earth and parallel rays and get different size shadows. So let's see how the flat Earth could falsify this conclusion. Number one, or A, where is the sun? I want an altitude. And two, or B, I'm going to give you a geographical position of the sun, a place that the sun is directly overhead, like Syene. And then I'm going to give you a distance from that, and you're going to have to accurately, within 1 degree, predict what the angle of that shadow is going to be. If you can't do both of those, you have not invalidated my conclusion.
Mama, please make them hear me, or I can't teach them anymore. This rabbit hole's too deep for me. Feel my brain getting real sore. Above the science guy, above the science guy.